I'm Dr. Craig Pullman, here to talk about the connections between attention and memory. Samuel Johnson once claimed that the true art of memory is the art of attention, and he was at least partly correct. To be sure, it's really hard to memorize something without first paying close attention to it. This makes intuitive sense, and is even more clear when we revisit the computer metaphor. Human memory is like a computer's hard drive and RAM. Attention, in terms of focus and concentration, is like Wi-Fi. In order to upload data to a hard drive, the computer needs a good, strong Wi-Fi signal. When the Wi-Fi signal is weak or turned off, the uploading process grinds to a halt, and it doesn't matter how big the hard drive is or how powerful the microprocessor is. That Wi-Fi signal can really be a bottleneck. The production controls of attention managemental output, including planning, pacing, impulse inhibition, and self-monitoring. Now, the production controls can actually help with memorization by getting the learner to slow down when studying. Effective studying usually requires first developing a plan. What's the scope of information on which I'll be tested? What kinds of questions will be asked? What strategies would help me learn the material? How will I know that I know what I need to know for the upcoming test? A student with weak production controls is not very likely to ask these kinds of questions. Rather, he will probably just jump into the material and zoom through it. So, Johnson was right that attention can bolster memory in several ways. But it's also true that memory can boost attention. Memorizing something to the point of automaticity means minimal effort or focus is required for recall. We experience this when learning how to drive. At first, you need to really concentrate on operating the car. But as you gain automaticity, your focus can move to what's happening on the road. Here's an academic example. When first learning multiplication, it takes a great deal of focus to remember facts. But over time, automaticity can be reached, which frees concentration for more sophisticated math thinking like reasoning and conceptualization. Memorizing something is a lot easier if you understand it. That's where the mind's microprocessor comes in. The thinking constructs, like language and higher order cognition, help one to make sense of new information. If comprehension is shaky, then the learner has to rely on rote memory, devoid of context or connections. Finally, some students have good attention, both processing and production controls, but still struggle with memory. Helping such students usually requires an emphasis on comprehension, active learning strategies, and mnemonic devices. The trick would be to develop a good filing system for that mental cabinet. I'll see you next time.